students! Today we will discuss about the different forms of electromagnetic waves and practical applications and effects of electromagnetic waves. Electromagnetic radiation is all around us. Some are unnoticeable, yet a lot of our activities make use of these electromagnetic waves, from texting to cooking. But what are electromagnetic waves? At the end of the lesson, you are expected to compare the relative wavelengths and frequencies of different forms of electromagnetic waves. Identify the relationship among wavelength, frequency, and energy of an electromagnetic wave. Cite examples of practical applications of different regions of EM waves, such as the use of radio waves in telecommunication, and explain the effects of electromagnetic radiation on living things and the environment. In your Science 7 class, you have learned about waves. Let's recall some important terms about waves. A wave is a disturbance in space. It transfers energy but not matter. Waves can transfer energy through solids, liquids, gases, and even in empty space, also known as vacuum. Crest is the highest point in a wave. Trough is the lowest point in a wave. The amplitude is the distance from the midpoint to the highest or lowest point of a wave. Wavelength is the distance between two consecutive identical parts of a wave. The frequency of a wave refers to the number of waves produced in 1 second. Range refers to the extent or the limits between which variation is possible. There are two types of waves: mechanical waves and electromagnetic waves. Some examples of mechanical waves are the waves in a rope or a spring, water waves or ocean waves, and sound waves. On the other hand, light waves, radio waves, and UV light are examples of electromagnetic waves. But what is an electromagnetic wave? Electromagnetic wave, or EM wave, or electromagnetic radiation, is a wave that is created as a result of vibrations between an electric field and magnetic field which moves perpendicularly with each other, hence known as electromagnetic wave. We recall Oersted discovery. According to him, a changing electric field produces magnetic field. A changing magnetic field is therefore produced around a vibrating charge. On the other hand, according to Michael Faraday, a changing magnetic field will produce electric field. Electromagnetic wave carries energy as it propagates. EM waves can travel through anything, even in a vacuum. They do not need any medium to travel through. They travel in a vacuum at a speed of 3 to the 8 meters per second. There are 7 different types of electromagnetic waves. They are arranged in gradual progression from the waves of lowest frequency to highest frequency. This arrangement is called electromagnetic spectrum. In order of increasing frequency, the EM spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray. Now let's strengthen your concepts regarding the different EM waves by comparing their relative wavelengths and frequencies. Wavelength is the distance between crest to crest or trough to trough. EM waves are bounded at different ranges, meaning each type of EM wave has upper and lower limits on the spectrum. Using this electromagnetic spectrum chart, we will determine the wavelengths of each of the forms of electromagnetic waves. We'll start from radio waves down to gamma rays. The wavelengths of radio waves range from thousands of meters to 30 cm or 30 centimeters. So the wavelengths of radio waves is greater than 1 times 10 to the negative 1 meter or 10 centimeters. Heinrich Hertz proved the existence of radio waves. Radio waves have the longest wavelength, so it can travel farthest among all the EM spectrum. Microwaves range from 1 times 10 to the negative 3 to 1 times 10 to the negative 1 meters. Its size is comparable to a coin. Infrared is 7 times 10 to the negative 7 to 1 times 10 to the negative 3 meters. It is called infrared because it is below red. Infra means below. Sir Frederick William Herschel discovered the existence of infrared light by passing sunlight through a glass prism. Visible light is 6.22 times 10 to the negative 7 to 4.55 times 10 to the negative 7 meters. Under visible light, red light has the longest wavelengths ranging from 6.22 times 10 to the negative 7 to 7 times 10 to the negative 7 meters. Orange is 5.97 times 10 to the negative 7 to 6.22 times 10 to the negative 7 meters. Yellow is 5.77 times 10 to the negative 7 to 5.97 times 10 to the negative 7 meters. Green is 4.92 times 10 to the negative 7 to 5.77 times 10 to the negative 7 meters. Blue is 4.55 times 10 to the negative 7 to 4.92 times 10 to the negative 7 meters. And lastly is violet, which has the shortest wavelength among all the visible light. It is ranging from 4 times 10 to the negative 7 to 4.55 to the negative 7 meters. Next to violet is ultraviolet light. It is called ultraviolet light because it is beyond violet. Ultraviolet has a wavelength of 1 times 10 to the negative 8 to 4 times 10 to the negative 7 meters. X-ray is 1 times 10 to the negative 11 to 1 times 10 to the negative 8 meters. While gamma ray is the shortest EM wave, which has a wavelength of less than 1 times 10 to the negative 11 meter. Observe what happens to the wavelength of an electromagnetic waves as they go rightward in an EM spectrum. Does the wavelength of the EM waves increase or decrease as we go from radio waves to gamma ray? Wavelength decreases from radio wave to gamma ray. We now discuss the frequencies of EM spectrum. Radio waves have frequencies less than 3 times 10 to positive 9 Hz. It has the lowest frequency among all the EM spectrum. The frequency of the wave determines the energy carried by the wave. So, radio waves have the least energy. Microwave's frequency ranges from 3 times 10 to the 9 to 3 times 10 to the 11 Hz. Infrared is 3 times 10 to the 11 to 4 times 10 to 14 Hz. Visible light, 4 times 10 to the 14 to 7.5 times 10 to the 14 Hz. Under visible light, we have red, which is 4 times 10 to the 14 to 4.82 times 10 to the 14 Hz. Orange is 4.82 times 10 to the 14 to 5.03 times 10 to the 14 Hz. Yellow, 5.03 times 10 to the 14 to 5.20 times 10 to the 14 Hz. Green is 5.20 times 10 to the 14 Hz to 6.10 times 10 to the 14 Hz. Then for blue, 6.10 times 10 to the 14 to 6.59 times 10 to the 14 Hz. And violet, 6.59 times 10 to the 14 to 7.5 to the 14 Hz. The next to visible light is ultraviolet light. Frequency ranging from 7.5 times 10 to the 14 to 3 times 10 to the 16 Hz. X-ray is 3 times 10 to the 16 Hz to 3 times 10 to the 19 Hz. And gamma ray has the highest frequency, so it has the highest energy. The frequency of gamma ray is greater than 3 times 10 to the 19 Hz. The frequency of EM wave increases from radio wave to gamma ray. Electromagnetic waves have practical applications which depend greatly on their wavelengths, frequencies, and energies. The following are some practical applications of electromagnetic waves. We'll start with radio waves. Radio waves are used in radio and TV sets. Radio and television signals are radio waves that are produced by making electrons vibrate. It has a long wavelength capable to transmit sound and picture information over long distances. Global Positioning System or GPS is a space-based navigation system that provides geographical position and time information anywhere or near the Earth. It communicates with stations on the ground using radio waves. Magnetic resonance imaging or MRI is a medical imaging technique that uses powerful magnets, computers, and radio waves to make detailed pictures inside your body. Microwave. Microwaves are used in satellite communication because it can penetrate the Earth's atmosphere. Microwave signals are transmitted by an antenna to a satellite which amplifies and retransmits the signal to an antenna in other parts of the world. This is how we communicate even from afar. Terrestrial communication. A cell phone is a radio transmitter at the same time it is a receiver that uses microwave. Cellular phones depend on overlapping networks of cells. Each cell has its tower that receives and sends microwave signals. The mobile phone has played a vital role in daily life activities. Microwaves also used in cooking. The microwaves in a microwave oven penetrate and agitate the water molecules within the food. Thus, they create molecular friction which produces heat that will cook the food. Radar. Radar stands for radio detection and ranging. It's a detection system used to determine the range, the angle, or velocity of objects. It can be used to detect aircraft, ships, motorcycles, and many others. Infrared. Infrared has many uses. Remote control or IR remote uses LED lights to transmit signals to control devices. It emits pulses of invisible infrared light. Thermal imaging through infrared scanners. Infrared scanners, such as thermal imaging and thermal scanner, are used to show temperature variation of the body. Our body radiates infrared, and under infrared cameras, our images appear in a variety of colors. The differences in color determine the differences in temperature. For example, shades of blue and green indicate regions of colder temperature, and red and yellow indicate warmer temperature. Night vision goggles. Night vision goggles use thermal imaging technology to capture the infrared light being emitted as heat by objects in the field of view. Visible light. Visible light enables us to see things around us. It also gives light to the screen of most electronic devices, such as the TV screen or the computer monitor. Artificial lights. Like, for example, the flashlights, the light lamps, are light sources that produce light instead of natural lights produced by the sun. Optical fibers. One use of optical fibers in medicine is endoscope. An endoscope, a flexible tube with tiny camera that is used to observe the internal parts of the body. Ultraviolet B or UVB radiation in sunlight interact with protein in the skin, converting it into vitamin D3. The active form of vitamin D is essential for maintaining healthy bones and teeth. Security markings. Sensitive documents such as credit cards, banknotes, include a UV watermark that is only seen under UV emitting light. Sterilization of water and drinking fountains. UV light disinfection is one water treatment system that can be used to remove most forms of microbiological contamination from water. Fluorescence. Some washing powder contains fluorescent chemicals which glow in sunlight. This makes your shirt look whiter than white in daylight. X-rays are used in diagnostic imaging, for example, diagnosing bone fractures. X-rays are produced using an X-ray tube. They are emitted with fast-moving electrons hit a metal target. Long-wavelength X-rays can penetrate the flesh, but not the bones. That's why it is used in diagnostic bone fracture. Airport security scanner. The short-wavelength X-rays can penetrate through metals, which can be used in airport security scanner. Gamma rays. Gamma rays are used to treat tumors and cancers through the process called radiotherapy. The high-energy rays of gamma destroys cancer cells in the area where it is given. Gamma rays are also used to sterilize surgical instruments because they easily penetrate through materials and the energy they release kills bacteria and other microorganisms. Electromagnetic wave, though it has many uses, it poses hazards if not used carefully. Radiation can be harmful if it is used in excessive amount. The effect of EM radiation on organisms and environment depends on how much energy it carries. Radiation can be classified as non-ionizing and ionizing radiation. Non-ionizing radiation does not have enough energy to remove electrons from atoms or from molecules. Examples of non-ionizing radiation are radio waves, microwaves, infrared, visible light, and UV rays. Every time we are exposed to sunlight, we receive low levels of non-ionizing radiation. However, when the exposure is intense and direct, it may result in damage to tissue due to heat. Right amount of non-ionizing radiation like UV rays maintain the proper mechanism of ecosystem. High-energy EM waves like X rays and gamma rays are examples of ionizing radiation. Like non-ionizing radiation, we are also exposed to low levels of ionizing radiation that comes from the atmosphere. This means that the usual amount of ionizing radiation from natural sources absorbed by our bodies is small. Our main exposure to ionizing radiation comes from man-made sources through the use of diagnostic medical procedure. Excessive exposure to these radiations can alter molecules within the cells and may cause eventual harm such as skin or tissue damage, cancer, or even death. When handled improperly, radioactive pollution may occur, which may result to contamination of air, soil, and water. This pollution may eventually make its way up to the food chain where all forms of life may be affected. So, in order for us to be safe when dealing with electromagnetic waves or electromagnetic radiation, proper handling is a must. To gauge your understanding in this topic, please answer the following questions. Number 1. Which type of wave has the shortest wavelength? Letter A, gamma ray, B, microwave, C, ultraviolet, and D, X-ray. The answer is letter A, gamma ray. Number 2. Which of the following statements is correct? Letter A, gamma ray has the highest frequency and the highest energy. Letter B, gamma ray has the highest frequency but has the least energy. Letter C, radio wave has the highest frequency and the highest energy. And letter D, radio wave has the lowest frequency but has the highest energy. The answer is letter A. Gamma ray has the highest frequency and the highest energy. Number 3. What happens to the frequency of the electromagnetic wave if its wavelength increases? Letter A. It decreases. B. It increases as well. Letter C. It remains the same. Or letter D. None of the above. The answer is letter A. It decreases. Number 4. In the electromagnetic wave, what is the direction of the propagation of the wave? Letter A. Always to the right. Letter B. Parallel to electric and magnetic field directions. Letter C. Perpendicular to the electric and magnetic field directions. And letter D. Cannot be determined. The answer is letter C. Perpendicular to the electric and magnetic field directions. Number 5. The energy of the EM wave depends on blank. Letter A. The amplitude of vibrations. Letter B. The frequency of the wave. Letter C. The wavelength. Or letter D. Any of the above. The answer is letter B. The frequency of the wave. Number 6. How do microwave oven cooks food inside it? Letter A. Food releases microwave frequencies that cook the food. Letter B. Microwaves cause water molecules in food to vibrate, producing heat that cooks the food. Letter C. Molecular friction is eliminated, thus cooking the food in a microwave oven. And letter D. Heat is released outside the microwave oven, which cooks the food. The answer is letter B. Microwaves cause water molecules in food to vibrate, producing heat that cooks the food. Number 7. Which of the following forms of electromagnetic waves is used mostly in communication? Letter A. Gamma rays. B. Infrared. C. Radio wave. D. X-ray. The answer is letter C, radio wave. Number 8. Satellite communication is an application of what type of wave? Letter A, infrared, B, microwave, C, radio wave, D, X-ray. The answer is letter B, microwave. Number 9. Sunburn is caused by too much exposure to blank. Letter A, ultraviolet light, B, infrared, C, X-rays, D, visible light. The answer is letter A, ultraviolet light. Last number, number 10. This type of EM radiation may damage the living cells, causing mutations and cell death. Letter A, gamma rays, B, infrared, C, ultraviolet light, D, visible light. The answer is letter A, gamma rays. So I hope you got all the correct answers from 1 to 10. So our next topic is images formed by mirrors and lenses. So we see for the next lesson.